We're doing properties of fractional exponents. This is section 7.2. Let's get started. All right. The properties of fractional exponents, all of these properties apply to the exponents when the exponents are fractions. We're going to see the properties of exponents that we've already covered. And it doesn't matter if their exponents are integers or if they're fractions or rational numbers. It doesn't matter at all. So the properties we already covered once before, if we have a base with an m and an n as the exponent, we just add them together. If those m's and n's happen to be fractions, it doesn't matter. We just add them together. That property is the same whether it's an integer or a fraction. We've already covered this one, that if this letter m here, we can distribute it to both the x and the y. It does not matter at all if these are fractions. We've covered this one also. If we have an exponent raised to an exponent or a power to a power, we just multiply them together. Again, it does not matter if they're fractions. Many of you are going to see the fractions and start to go, oh no, that's terrible, but that's not a problem. They work the same. And the great thing is you have a calculator that adds fractions for you, so you don't have to stress about that. You don't have to worry about finding a common denominator and all that stuff. If we're dividing, we subtract the exponents. It doesn't matter if they're fractions or integers. It works the same. If we're dividing, we can distribute that to both of them also. Works the same. And the last one, if you have a negative, you put it downstairs and it becomes positive. We've done this before. If it's a fraction, it works the same. So let's do some. This is going to be part of your homework that we're going to do numbers 1 and 2, so go ahead and get those out. Numbers 1 and 2, we'll do them together so that you have examples to look at when you're doing your homework. I personally, when I'm doing these, I like to do the coefficients that don't have, they're just the numbers in front with it, the coefficients. So I have a 2 and a 2, and that totals to how much? 4. So I'm going to write 4 on there. We're multiplying. Then I take the letter B. That seems to be the next one over. Are there anything to combine for that B? No. So it's just 4B. Now A, you asked a really good question a moment ago, Isaac. Are we multiplying or adding? It depends on what we're talking about. We're multiplying those two monomials together. But what do we do to the exponents when we're multiplying?
1/5.
We add them together. So to add them together, you could get a common denominator and do all that, or you can get your calculator out and take 1/2 plus 1/3, which is 5/6. So it's 5/6. We add those exponents together. All right, then let's go on to number 2. We're going to do our coefficients again. That's the numbers that aren't exponents at all. We have a 2 and a 2 that make 4. Yes, ma'am.
Can I put the U next so that when I have my...
You can do your U next. Yes. U does not have anything with it, right?
Correct.
So it's just U.
My exponents in the back.
Yes. And then V. What are we going to do with the 5/4 and the 2? Add them.
1/4.
That's going to be 2 over 1, which is the same as 8 over 4. Yep, 13/4 is what I got. Your calculator does that for you if you'd like. Or you can get a common denominator like I did. All right. Let's move on to number 5. Move on to number 5. What do we do to the 1/4 and the 3/2 here on number 5?
You multiply them?
Yes. The nice thing about multiplication of fractions, you should multiply the numerators and the denominators. So when you multiply the numerator, what do we get? We get 3. Yeah, we got n to the 3 over 8. And make sure you always reduce that fraction if you can. Okay? N to the 3/8. Questions? That's why we spent some time a while ago doing all those properties of exponents. So we didn't lump them all together with these fractions. We could practice the I'm going to do air quotes here, easy ones before we do the harder ones.
More like easier.
All right, now we've got a B and an A inside the parentheses for number 6.
So we distribute the 3.
We're going to distribute the 3 over 2. That's correct. So we're going to have B to the 3/2, but A to the
21/8.
yes, very good.
Which can't be reduced.
That's correct. It cannot. All right, we're going to move on to number 11. We're going to move on to number 11. More parentheses, but larger now. We now have an exponent that we're going to distribute to all of that, but we could combine some inside the parentheses first. You need to decide. It won't matter what we do. We can combine first or distribute first.
I want to combine first.
You want to combine first. That's kind of a general consensus. Okay, so I've got an M here to combine. I got a M, we got a 1/2 and a 1/3, and we need to add that.
5/6.
Please make sure that she's correct.
5/6.
Okay. Let's do N now. I've got a 2/3 and a 1/2. When I add 2/3, what do I get?
7/6.
Don't forget to keep that squared. Don't forget to keep that squared. What do I do with that squared? Distribute it to everything. So we'll have M to the...
I thought we were distributing it to the exponents.
We are. So we're going to multiply these together. You are right. We're 5/3, okay, when we multiply. And then we have an N, and we're going to multiply the 7/6 and the 2. That'll be 14/6 reduced 7/3. Be really careful. Mine are kind of hard to see. Make sure those are definitely exponents. They don't accidentally come down and sit next to those things. Make sure they're definitely flying in the air up there. We're going to do number 12. This time we have to give the 3/4 to both of those before we combine with our x squareds because it's outside. So we're going to give the 3/4 to both of those. We'll have x to the 3/4 and y to the what?
9/8.
I heard 9 what?
8.
And how did you get 9/8? Multiplied. Do we agree that it's 9/8? Then x squared. Can I combine something together?
The x squared and the x squared.
Yes. What do I do with the 3/4 and the 2?
You add them, right?
They add them. That's correct.
11/4.
That's what I got. X and 11/4. X to the 11/4, y to the 9/8. All right, we're going to do number 15. You've seen these similar last lesson, but we're going to multiply these. When we multiply and they have the same roots, like this is a square root and a square root, we can just combine them together. We can take the 15 and the 6. There are a couple ways to do this, so I want you to just watch first, and then you pick which one you like the best, okay? You could, on your calculator, multiply 15 and 6, which is going to be... Someone tell me what 15 times 6 is, please.
90.
90?
Yeah, 60 plus 30.
Okay, yes. That's 90. And then you can come over here and do 90 on your... which is 9 and 10 and 3 and 3, which is a perfect square root, and 2 and 5, right? Yeah. Then you can start taking things out. We'll take that 3 out. It already has a 5 there, so we'll have a 15, and we'll have a 10 there, okay? That's one option, a way you can do this.
That looked so cool.
Okay? The other option, I'm going to actually just squeeze this, move it over so you can see both of them together. I'm going to squeeze it over here. All right, the other option is to just start doing your factor tree right now. 15 is, and put it all under 1. Bring it all under 1. You have a 5. 15 is what?
3 and 5.
3 and 5. And
2 and 3.
2 and 3. Do I have any doubles right now?
3.
A 3, right?
Where do
So-
you get the 2 and 3?
This 2 and
Oh,
3
6.
is from the 15.
Got it. We're good.
Got it? Good. And then that 2 and 3 was from the 6. So I'm going to bring out these 3's, correct? Right
Yes.
there. To make 15 out here. And then we have this 2 and 5 left over with a 10. Okay?
That's just like skipping a step.
Right, it is. What I did is, see here you
just
brought
multiplied
it
it.
together, then tore it apart. Here you didn't worry about putting it together, you just start tearing it apart.
Yeah.
But some people need to put it together first. So I just want to do whatever you want. You pick what you want. I like this second method better because I don't want to put it together and then tear it apart when I could just start with the tearing apart. Let's do the next one. Right here. All right. So we could put this all under 1. I have a -5 on the outside. I have a 3 and a 2 from the coefficients. And we have an n squared and an n.
Can we combine the ends?
We can combine them if you want, but we're going to take out doubles anyway.
So the n
Oh,
squared.
so just take out the exponent.
Just take out the n squared, right?
Okay, yeah, then everything else would
Then everything else just stays in, right? So we'll have negative 5
n
n
square root 6. N.
square root 6n. At some point, this step for some of you might not be necessary.
I already feel like for that one at least it wasn't, just because there was nothing to break apart first.
Right.
But for others, I think I need to write.
Yeah,
it down.
because you right here, you could just take that n squared out. There was no thing to come together. Yeah.
Are we gonna do 19? Okay.
Yes, we're going to do 19. Let's do it together. Number 19 is a distributive property. We're going to distribute that square root of 5 to the first thing. So we'll have a negative 2. What happens to square root 5 and square root 5? What does it become? Just plain old 5. Are you with me?
No, I'm actually not familiar with this concept.
Because square root of 5 times, it's a double 5. So you're going to have,
Oh, so it comes out.
yeah, so it comes out. Exactly.
Okay, I see it now.
Okay, got it? So that's going to be times 5, which, and we'll bring it together as a 10 in a minute, plus, we're going to bring that square root of 5 times the 2.
That's 2 square root 5.
That's 2 square root of 5. I'm going to simplify this down to what?
Negative 10 plus 2 to the square root of 5.
And I can't bring those together because they're not like terms. One of them has a square root of 5 and one does not. Let's do number 21. Number 21. We're going to do the distributive property again. This time we have an x in there. Didn't have an x before. We're going to multiply the negative 5 square root of 15 times 2. What does that become?
Just negative 10.
Negative 10 square root 15. Next, we're going to multiply these together. Negative 5 times square root 15 times negative 3 square root 5x.
Can we combine those because with the x?
Yes.
So would it just be take out a double? So would it be like positive 15 and then the square root of 3? Maybe take out the 5. So
I'm going to do it, you're doing all that in your head, and that's great. I'm going to make that 15 become a 3 and a 5, and I have another 5, correct? And an x.
Where'd you get the 15
the
from?
15 is when you multiply the negative 5 and the negative 3.
Okay, got that. Where did I get these 3, 5, 5x?
The square root 15 and the square root 5x.
Mm-hmm. This is the square root 15, and that's the square root 5x, okay?
Nothing can come out though.
Nothing can come out, I heard.
Wait.
2 5s can come out.
2 5s can and
Yeah.
the x can stay.
Because the x is
Yeah, so the 3 and the x can stay, and the 2 5s can come out, right? So I'm going to bring down my negative 10 square root 15. My positive,
But wait, don't you need to add the 5 to the 15? Or does it not? Because
I do. This 15 that I just wrote here was from the 15 that's there.
No, I mean like in a second. The 2 5s.
The second one, yes. What are we going to do with this double 5? It's going to become a single.
5.
We do what to it? Add it or multiply? Multiply it. Multiply it. This is going to come out as a 5, and it's going to multiply to that 15.
75.
75, I heard.
Where are we getting the numbers from?
Okay, let me write. I'm coming back. Here we go. All right. So the question was, are we done, or can we combine the square root 15, these two together?
Yes.
All right. So the coefficients, those are coefficients like 3 and 10.
Yeah.
And these square roots are similar to like variables like x and y.
Can we just divide by 3 and then divide by 5?
I cannot put those together because they have we're multiplying by different things.
Okay.
So we cannot bring those together because they're not like terms. The only way we could bring those together is if they had the same square root. Square root 6 and square root 6. All right, number 23. We ready?
Mm-hmm.
This is not a distributive property. It's not a square root. It's a fourth root. There's a negative out front. That negative doesn't affect anything. Since it's a negative and a positive, it becomes negative when we're done, so it can just be done. That 108, I want to break down 108 into its pieces. What is 108 when I break it down?
Factor tree that?
Yes.
Oh goodness.
I'm going to say 2 and 54. Is that correct?
This is not the Monday to do that.
2 and...
27.
Oh, and 27 is 3, 3, and 3. Do I have any fourths to bring out?
No.
No, but I'm going to write it in there. So I have a 2, a 2, a 3, 3, and a 3. All right? And I have an x to the 5th. I can't take anything out yet, but that 6 can be broken down into what and what?
2 and 3.
2 and 3 in it, and it's got the x there.
What about the 4? Square root of 4 up there.
I think we just leave that to the end, right?
This is really a 4th root. I'm sorry, I don't understand.
Yeah, it's a 4th root. That's
Okay.
what
Forgot that part. Sorry about that. All right. What am I going to do? Take out what?
the 4 3s.
The 4 3s. Oh, fantastic, because I got 1, 2, 3 of them. All right?
4.
Then you take out 3 x's as well.
4 of them. And can I take out some x's?
Yeah, 3 x's.
Yes, I can take. We actually want a group of 4.
X's, sorry.
4 x's.
So it'll just be 2 x's left over.
Yes. So I'll have a negative 3x, because you wanted to take that out. What will be left inside?
Oh goodness, 1 second. We.
6x squared.
Not 6. Be careful.
8.
It's 8.
8. Yeah.
8 and
We're
how?
taking the x out too with the 3 at the end.
That's correct. One of these x's comes out, and I'll have 2 left there.
Yeah, that'd be 8.
Negative 3x outside. What's left? How many x's are
8
left on the
squared?
inside?
8x squared?
Yes.
Oh yes, that should be a 1 there. Yes, x squared. Thank you.
Why is there 1 there?
We took 3 of them out. 4 of them out. We took 4 of them out because it's a 4th root. We took 4 of them out, so there's 1 left.
But then we have another
That
x
makes
over
a lot
there.
We have another left there. Okay. All right, number 25. We're still doing a 4th root. Got negative 3 on the outside. Right now, I'm not going to worry about. I'm going to have a long square 4th root. You want to do all our we can put all our numbers. See, before I kind of split them up, I put up the numbers, letters, numbers, letters. Do you want to put all the numbers together and then all the letters together, or how you want to leave it, do it how we were doing it,
I
or
really don't mind it all over the place. It's up to you.
Same thing we've been doing.
let's just keep it how we've been doing it.
Don't
Okay, let's do our 8. How do we break down 8?
2, 2, and 2.
2, 2, and 2. And p squared. What about 40?
Let's see. 2, 2, 2. 3 2s and a 5.
3 2s and a 5. Yeah, okay. 2, 2,
You didn't get
2,
that, Natalie?
5.
Yeah. Good job. Thank you.
P4. Okay. We want to take out groups of how much?
4.
Groups of 4. So here's 2, 3, and 1 more. So we can bring out a 2.
And then we can bring up the p to the 4th.
And we can bring out a p to the 4th. So that total one right here would be the best one to do, just right there, right?
Mm-hmm.
Okay.
So outside, here we go.
What's going to be on the outside?
Negative 6.
Negative 6, because the 3 and the 2 come together to make,
And then
yes.
P.
4th root.
No, just P, right? Negative
No,
6P.
negative
Because we took out a
6P.
P4.
We have an
Negative 16.
extra, we have an extra 2 2s and a 5.
Negative 6p on the outside.
Yes.
Cool.
What's
Now
on the
we're
inside?
Me and our ourselves.
Now we're inside.
Okay. So then we have, let's see, 20.
I got 20.
Yes.
P squared.
P squared. I want to make sure everyone's with us.
Yep.
I might, if I was you guys, I might do all the 8 and the 40 and put those together,
That's what
and then
I
the
did.
P's and put them together. That's just
what
up
I
to
did.
you, though. I mean, you can organize it how you like it, but I didn't. You asked me not to change it up, but it might be might be better organizing to put all your numbers first and then all your letters left. All right, now we're going to do dividing. We've multiplied all these all along, and now we're going to do dividing. Dividing is a little different. Dividing is also called, you might want to write these words down, rationalizing the denominator. Okay? Rationalizing the denominator. I don't know who wrote this rule. I know why they wrote the rule a long time ago, but I don't know who did. There's a rule that says you cannot have a radical in the denominator. Okay?
I'm still struggling with the radicals.
The whole word radical. That means kind of a root. Okay? Square root, cube root, fifth root, sixth root, radical. This little symbol that I write here is called the radical. Okay? So I could call this square root 3, or I could call this radical 3. Either one. Okay? All right. So we can't have a radical in the denominator, so we have to get that square root 3 out of there. But we cannot change the value of it. So if I put that in my calculator and I get a decimal value, after I'm all done, I better be able to put that answer in the calculator and get the same value in my calculator.
We can't factor tree these because
We can't factor tree this at all.
So do we multiply it by itself?
We multiply the denominator. Yes, we multiply it by square root 3 over square root 3. This is some, we might remember these. We've done these.
I just
sometimes.
guessed based off what you said.
So, the denominator, what does the denominator become? Square root 3 times square root 3 becomes plain old 3. We no longer have a radical in the denominator.
But then do we have 15 at top?
We have square root 15 on top. If you were to put the one I've circled, square root 5 over square root 3, in your calculator, you will get the same value as if you put that in your calculator. You can prove it. You don't have to. I'm just telling you, you will. The reason is because all we did really is multiply by 1. Square root 3 over square root 3 is just 1. We just multiplied by 1. It just looks different. We made it look different. Okay? Let's try number 29. What am I going to multiply by 29 to get that radical off the denominator?
Are we done?
We're done. Ta-da!
Well, it's not going to be because the others we're going to have to simplify.
You.
All right, so when I do number 29, what am I going to multiply by?
The square root of 10.
Square root of 10 over the square root of 10. This is really multiplying by 1 because the top and bottom is the same.
Mm-hmm.
But I'm making it look different. On the denominator, I'll have plain old 10. What will I have on the top?
50.
Square root 50. Very good. Now, the numerator, or excuse me, the top one, number 27, we could not do a factor tree on 15 and get anything to take out.
Oh, so you have to
But 50 we could, so you need to check. What is 50 when I do a factor tree?
5
and 2. So you can take 2 5s out. And then
Yeah,
you can
it's
simplify it even
25 and 2 and 5 and 5 and...
No, it's just 5, 5, and 2.
Yeah.
Oh.
Yeah, I just did it differently than you did.
You just did it the drawn out way.
Yeah.
I just did it. I wanted to show everybody.
No, don't go ahead. Go ahead.
Okay. I got 5, 5, and 2, so I'm going to take what out?
5 out.
5 out.
But then you can simplify it again.
Then I can simplify it still.
So that becomes like 1/2 the square root of 2?
Yes! Or square root 2 over 2.
Oh, because the 1 just...
Because the 5 goes in there 2 times, right?
Oh, can I leave the 1? Like, will that count as incorrect?
Okay, so
can
you
leave
just
one.
cancel out the 5.
Yes.
Okay, that makes
Okay.
sense.
You can put the 1 up there, Natalie, if you want.
I'm going to write or just so I know.
Yep.
And then...
It would have been the same, Natalie, as 1/2 square root 2 also. You could have written like that, too. Because these are both numerators.
We'll just see what my hand does.
I like that one better. All right. Let's do number 31.
Delicious. Yay.
What am I going to multiply on the top and bottom?
Square root 15.
Just the square root of 15. The 3 is extra. You don't really need to multiply it on top and bottom. This is why we practiced the distributive property a moment ago. What is 15 times 15? Square root 15 times square root 15?
15.
15 times the 3 is 45. Now we got to do the distributive property on the numerator. We have to take that square root 15 times the 4, which is...
4 square root 15.
And the square root of 15 times 5.
Square root of 75.
We could do the square root of 75, but we're going to take some stuff out. I personally like to think of 15 as 3 times 5, right?
Yeah.
This is 3 times 5. There's another 5.
So 5 square root 3.
5 3 underneath.
3 would be in the underneath, 5 would come out.
Yeah.
Yeah.
But the 5 can reduce the 45.
The 5 and the 45 can reduce, but you have to be able to reduce all of them to reduce it. So we're done. Okay. If this was a multiply, Heidi, we can do all we want. But when it's a plus, if there's a plus or minus, then they all have to reduce to be able to reduce
So
it. Number 33. Number 33. Now we have an addition in there with those square roots. And so we're going to multiply by what's called the conjugate. And you have heard of this. You heard of conjugates earlier. The conjugate of square root 2 plus square root 3. Does anybody remember what it is?
I have no idea what conjugate means.
It's, instead of doing square root 2 plus square root 3,
Oh, wait, didn't you just say
it's
you combine them?
with square root 2 minus the square root of 3. We do the same as these, except remember back when we did 2 plus
yeah,
I, and I
flip
said,
on.
what's the other root? It was its
2
conjugate.
minus I.
It was 2 minus I. Remember, those were conjugates? Well, we now have the conjugates of those. When you multiply two conjugates together, the middle terms cancel out. It's the difference of squares. Do you remember? So I'm going to do one. If I have x plus 5 and x minus 5, you guys know really fast how to multiply that without doing all the middles. What's that going to become?
X squared minus 25.
Very good. You don't have to do the 5x and the negative 5x and have them cancel. That's extra work because you know they're going to cancel. That is exactly what's going to happen. By the way, these were conjugates. X plus 5 and x minus 5. They're conjugates.
Conjugates mean.
Meaning that's the same thing except one you have a negative and a positive. Okay?
Like a partner.
So when I multiply those together, there'll be difference of squares. So when I multiply these together, it's going to be a difference of squares. It's going to be square root 2 times square root 2, which is
2.
minus square root 3 times square root 3, which is
3.
3. No. But notice there's no radical now. It's
1.
gone.
Can I just simplify that automatically, make that a 1?
Yes. Negative 1.
Thank you.
What? Oh.
All right. Now I have to do the numerator, correct?
I don't understand. I understand where you get you just took out the square root. Yeah, I understand.
Got it? Okay.
So,
Now we're going to do that 2 to both. That's multiply. That was not equals, by the way. That should have been a multiply.
Problem got me like.
We're multiplying those. I'm going to have 2 square root 2 minus 2 square root 3.
And then we're done.
Then we're done. 2 square root 2 minus 2 square root 3. Really, with that negative 1 on the bottom, we could just write it negative. 2 square root 2 minus 2 square root 3.
What will the answer key be?
This. Or, Heidi, I'm not sure. The answer key might be it distributed. It might
If we
even be
leave
negative
it
2
like
square root
that,
2
will
plus
you
2
count it
square root 3.
right? The top
Yes.
Right. That's the answer. That's a good answer.
Okay. All right, number 35. What are we going to multiply by top and bottom?
Negative.
Square root of 5. Right?
Negative 2.
Square root of 5.
What's going to be in the middle between them?
minus.
Minus. Good job. Top and bottom the same. We did that, and I did it again. It's not an equals. It's a multiply. Okay. So we did this because we wanted the difference of squares, so the middle terms will cancel out. When difference of squares, I'm going to have negative 2 times negative 2 becomes,
Positive 2.
uh-huh.
Positive 4.
Yes, ma'am.
No.
And
I said the negative 2 first.
2 square root 2, 2 square root 5 and 2 square root 5.
No. It becomes
10?
0.
I get something else. The 2 and the 2's become 4, and the square root 5 and the square root 5 becomes 5. So it's going to be 20. Are you with me?
No.
Oh yeah, they come out as just a 5.
Yes.
Oh,
So
you're
then they multiply with the
multiplying,
4.
and then you multiply the 4 by the 5, and negative 5. 4 by negative 5. Negative 5.
Yes. Got it now?
I think so.
Okay.
Sure.
Now we're going to do the distributive property. I've got this. Square root 3 times negative 2 is negative 2 square root 3. Minus, what's the orange one going to become?
Negative 2 square root of 3.
Very good.
What?
What?
4 minus 20 is negative 16. And we have negative 2 square root 3. I'm going to keep it in that color just because we don't want to have any heart attacks. 2 square root 15. Can we reduce this?
No.
We do. Yeah, we can take 2 out of both. A negative 2
2 out of everything.
Yes. Yeah, we can take a negative 2 out of everything. So we will have.
Wait.
Square root of 3, square root of 15 over 8.
What goes in between?
Middle?
A plus.
Yes. All right, are we ready? This is what you learned in this lesson. You learned that the properties of exponents still apply to fractional exponents. Nothing's changed. We learned how to rationalize the denominator. Goodbye.